Good morning to everyone. My name is Sri Tejashwini from 3CSE. Today my topic is about NFA with epsilon NFA epsilon transition to NFA without epsilon transition from flat. Formal language and automata theory. Topic is convert NFA epsilon to NFA. So NFA epsilon to NFA. In this method, we try to remove all the epsilon transitions from the given non-deterministic finite automata. So NFA is non-deterministic finite automata. NFA is of the alphabetic values like A, B, C, 0, 1, 2, 3. These can be of inputs can be of the required one. No need to mention all the inputs like DFA. So the method is mentioned below stepwise. First, step 1, find out all the epsilon translation from each state Q that will be called as epsilon closure. So closure Qi, where Qi belongs to Q. So from the diagram, first step is we find the epsilon closure values. So for every state like A, B, C or Q1, Q2, Q3 or 1, 2, 3, so on, for every state, there will be some epsilon closure. If there is no epsilon from one state to the other state, then the state itself will be considered in the epsilon closure. If there is state from 1 to 2 epsilon closure, then the epsilon closure will be of 1 and 2. So step 1 is finding for all the states the epsilon closure will be found. Next, once the epsilon closure is found, they are kept aside, and the step 2 is then delta 1 transition can be obtained. The delta 1 transition means the epsilon closure of delta 1 moves. Delta moves. So transition from the diagram, the transitions can be obtained. And step 3, step 2 is repeated for each input symbol and for each state of NFA. So when the delta is taken, and that delta values will be found for every input and for every symbol, for every input and for every symbol. For example, if there are 3 states like A, B, C and inputs like 0, 1, for A0 will be finding the epsilon closure of delta values, and A1 will be finding the delta values. And similarly B0, B1, similarly C0 and C1. So for everything, for every state and input, for every input alphabet, the delta values will be found. Once the delta values is found, step 4, by using the resultant states, the transition table for equivalent DFA without epsilon can be built. So epsilon closure values will be used at the last, and by seeing the epsilon closure values, the NFA without epsilon transition diagram can be built by those states. NFA with epsilon to without epsilon is as follows. So delta one of QA. Every Q is the states A, B, C, Q, and Q2. Like Q is a state and A is the input alphabet. So first the epsilon closure of delta cap of Q1 comma epsilon comma A. So closure is obtained here. Next, delta cap of Q comma epsilon is given, right? Further, the epsilon closure values are taken, and after epsilon and delta of epsilon closure values are taken from the input alphabets. Those values are taken, and those values epsilon closure will be found. So delta 1 of Q comma A is the epsilon closure of those values. So let us see an example, then you'll get a clear view. So for example, if the NFA with epsilon closure is this diagram, now they convert this into without epsilon. So solution is, first we obtain epsilon closure of each state. See, there are 3 states, right? Q0, Q1 and Q2. The start state is Q0 and end state is, final state is Q2. What are the input alphabets? 0, 1 and 2. So input alphabets are 0, 1, 2 and states are Q0, Q1, Q2. So for every state and for every input alphabet, the epsilon closure will be epsilon closure should be fine. So epsilon closure of q naught. So first state q naught, epsilon closure is q naught itself, and epsilon closure it moves to q1, and again epsilon closure it moves to q2. So epsilon closure of q naught is q naught, q1, and q2. So here it is epsilon closure of q naught is q1, q1, and q2. And next, so q naught is completed now. Now move to q1. So the q1 epsilon closure of q1 is q1 itself, and the epsilon closure is moved from q1 to q2. So q2 is also an epsilon closure. So epsilon closure of q1 is q1 and q2, right? Next, q2 is completed. Now move to q1 is completed. Now move to q2. So epsilon closure of q2 is q2 itself, and there is no other epsilon closures, right, connected to q2. So epsilon closure of q2 is only q2. So epsilon closure of q2 means with null input, no input symbol, we can reach q0, q1, and q2. In similar manner, for q1, q2 epsilon closures are obtained. C. Now we'll obtain for delta 1 transitions for each state and for each input symbol. Delta dash of q0 and 0 equal to epsilon closure of delta cap of q0 epsilon 0. So first here q0 comma epsilon, delta cap of q0 on epsilon is epsilon closure of q0. Epsilon closure of q0 is what? q0, q1, q2, right? So in this delta cap of q0 and epsilon, we'll write the q0, q1, and q2. q0, q1, and q2. So epsilon closure of q0 is q0, q1, and q2, and that delta of q0, q1, and q2 of input symbol is 0. So q0 of 0 union q1 of 0 union q2 of 0. So delta of q0 of 0, q1 of 0, q2 of 0, the values will be taken. So from diagram q1 comma 0, from q0 0, where it is going for the input 0, q0 itself. So the q0 is written. q0 of 0 is q0. Next union. q1 of 0 is for q1 there is no input 0. So it will be 5. 5. Next for q2 also similarly for q2 there is no input for 0. So it is 5. So q0 union 5 is q0. So again epsilon closure of q0 is q0, q1, and q2. So delta of q0 comma 0 is q0, q1, and q2. Next, delta dash of q0 and 1. Now the input is 1. As we know, delta closure of epsilon closure of q0 is q0, q1, q2. Epsilon closure of delta of q0, q1, q2, comma 1. Now for every state, the input symbol is taken q0, comma 1, q2, comma 1, q3, comma q2, comma 1, q1, comma 1. So q0, comma 1, no output. So 5. Next for q1, the input value 1 is q1 itself. Next for q2, input alphabet 2, 1 is no output. So only q1 will be there. That means 5 union q1 union 5. So like this we got, and by using union operator we get only q1. So epsilon closure of q1 is q1, q2, q1, q2. Next, similarly, we'll be seeing the q1 comma 0. q1 comma 0 is q1 comma epsilon comma 0. So first q1 epsilon closure of q1 is taken. Epsilon closure of q1 is q1 and q2, right? q1 and q2 comma 0. No, now for q1 and q2 both states, the input alphabet 1 is taken. 1 is taken, and now delta of q1 comma 1, q1 comma 0 and q2 comma 0. q1 comma 0 is not there, q2 comma 0 is not there, the output is not there. The input for q1 is only 1 and q2 is only 2. For zeros inputs there are no outputs, so it is taken as 5. Epsilon closure of 5 is 5. Similarly q1 comma 1, next q1 comma 2, next q2 comma 0, next q2 comma 1, next q2 comma 2. So like this all the delta values are calculated in here. Now the transition table is of before we got the q naught, right? For q naught comma 0, we got q naught, q1, q2. So q naught for 0 input, q naught, q1, q2. Okay. Next, for q naught 0 1, like q naught and 1, we got q1, q2. Means q naught for 1, q1, q2. Okay. Next, for 1 and 0, q1 and 0, we got 5. For q0, for q1 and 0, we got 5. Okay. Next, for q1 and 1, q1, q2. For q1, 1, q1, q2. Next, here q2 comma 0, 5. See q2 comma 0, 5. Next, q2 comma 1, 5. q2 comma 1, 5. Next, q2 comma 2, q2. q2 comma 2, q2. See, so these values will be drawn from the delta epsilon closures of delta. So now the table we got q for q naught 0, q naught, q1, q2. So this table will be represented in a diagrammatic way, and that diagram will be the NFA without epsilon. So as there are three states here, q naught, q1, q2. Again, we'll be writing three states, q naught, q1, q2. Now for q naught at 0 input, it moves to q naught, q1, and q2. So this will be the diagram. So q naught at 0 input, it moves to q naught and q1 and q2. So 0, 0 input. And next, at q naught at 1 input, it moves to q1 and q2. So q naught at 1 input, it moves to q1 and q2, right? And q naught at input 2, it moves to only q2. Q naught at input 2, it moves only q2. So for q naught, now the diagram is completed. Next, for q1 state, for q1 not q naught state is completed. Now q1 state, for q1 at 0, 5. So no need to draw any input, any line for 5. So q1 at 1, q1 and q2 at 1, q1 at 1, q1 and q2 at 1. Next, q1 at 2 input, it moves to q2. q1 at 2 input, it moves to q2. At 2 input, it moves to q2. Okay. Next, at q2 at 0, q2 state, 0 input is 5 and 1 input is 5, and at 2 input, it moves to q2. So self loop. Okay. This is the NFA without epsilon. This is so the diagram NFA with epsilon is this one, and this is converted to the NFA without epsilon. Thank you.